Hello students, in the previous lecture we studied the law of conservation of angular momentum, that is this here, that is angular momentum, that is omega equal to constant when the torque acting on that rotating body is 0. In this lecture we are going to study the rolling motion. Then what is this rolling motion, or what is meant by the rolling motion? Here we consider a spherical body or a cylindrical body or a hollow cylinder or a sphere for doing this rolling motion. Let us suppose this sphere is rolling on this horizontal surface like this. Here, in this case, it is the combination of two types of the motions. It is combination of two types of the motions. That means, if the sphere is rolling like this, if there is no friction, the condition, if there is no friction, it will be just slip. That means, in case of this rolling motion, the friction is important. Friction plays an important role. But in case of this rolling motion, it is combination of two motions, that is translational motion plus the rotational motion. Then how it is possible? If we consider this spherical body, that is a symmetric body. The spherical body is nothing but a symmetric body. Here we will draw the diagram for the spherical body. And if it is a spherical body, all the mass is at its center. That is, the center of mass of this spherical body is at its center, suppose. And all these particles are moving along this center. That is, here is the point. That point is called as center of mass of the body. Suppose this spherical body having mass m moving with linear velocity, suppose v, on this surface. Suppose it is at point A. What happens in this case? This center of mass of the particle does not move. It can just translate from one point to another point. आता एक ठिकाणी थोडंसं आपल्याला इमॅजिनेशन करावं लागेल. Suppose it is at point B. की ज्यावेळी या ठिकाणी हा स्फेरिकल बॉडीशी या ठिकाणी मूव्ह होते फॉरवर्ड डायरेक्शन, त्यावेळी या ठिकाणी ही टोटल जे पार्टिकल्स हे रोल होतात अबाउट इट ऍक्सिस ऑफ रोटेशन. त्याच्या ऍक्सिस ऑफ रोटेशनला हे टोटल पार्टिकल काय होतात, मूव्ह होतात. म्हणजे या ठिकाणी एक्झॅक्टली हे पार्टिकल फॉरवर्ड डायरेक्शनला जाते आणि या ठिकाणी आपला जो सेंटर ऑफ मासचा पार्टिकल आहे तो कुठे स्टेबल. इट कॅन जस्ट ट्रान्सलेट फ्रॉम वन पॉइंट टू अनदर पॉइंट. दॅट मीन्स द सेंटर ऑफ मास ऑफ द पार्टिकल परफॉर्म्स translational motion, and all these particles revolving around this axis of rotation performs rotational motion. That is, this rolling motion is combination of two types of the motion. That is, this rolling motion is combination of translational motion about its center of mass plus रोटेशनल मोशन. म्हणजे या ठिकाणी दोन टाइपचा मोशन सेल बघा. थोडंसं इमॅजिनेशन आपल्याला करावं लागेल की या ठिकाणी हा जो सेंटर ऑफ मासचा पार्टिकल आहे हा फक्त काय होतोय, ट्रान्सलेट होतोय ए पासून बी पर्यंत. परंतु ह्या पार्टिकलच्या अराउंडला या पद्धतीने बघा, ह्या पार्टिकलच्या अराउंडला बॉडी काय होते, मूव्ह होते. मूव्ह होतानाच पुढे पण जाते, मूव्ह होताना फॉरवर्ड डायरेक्शनला जाता येते बघा. म्हणजे त्या ठिकाणी ती मोशन कुठली, अबाउट ऍक्सिस ऑफ रोटेशनला रोटेशनल मोशन. म्हणजे रोलिंग मोशन कॉम्बिनेशन. दिसताना दोन्ही सेम वर्डिंग वाटतं आपल्याला, रोटेशनल आणि रोलिंग, बट इट इज रोलिंग मोशन इज कॉम्बिनेशन ऑफ दिस ट्रान्सलेशनल मोशन प्लस दी रोटेशनल मोशन. ओके, देन as it is in motion we have to find out the kinetic energy of that rolling motion. मग आपल्याला काय फाइंड आउट करावं लागेल, रोलिंग मोशनची कायनेटिक एनर्जी आपण काय करू या ठिकाणी फाइंड आउट करू. and it can be again the combination of this translational plus rotational motion. That is, to find this kinetic energy, that is the total kinetic energy of this rolling motion is the combination of kinetic energy of translational motion plus kinetic energy of rotational motion. Suppose equation number 1. And as the body or this spherical body with mass m moving with velocity v, as it is, all these particles are moving around this center. Therefore, it has, suppose I is the moment of inertia of that rotating body, and it is given by I equals to m into k square. My body is rotated to the center. It can have moment of inertia time about axis of rotation m into k square by the definition of moment of inertia. Then, as we know that if it is having linear velocity and all the particles are moving with angular velocity omega, the relation is P equal to R into omega, where R is the radius of that spherical or the rolling body. I is equal to m into k square, and we already know that the total kinetic energy of this rolling body is nothing but sum of kinetic energy in case of translational motion. Therefore, in case of translational motion, the kinetic energy is given by half into m square. Half like the 11th standard of the formula, half m into k is the v square. If body is moving in straight line of the linear, then we already derived the expression for that kinetic energy of rotating body, that is half I into omega square. Suppose equation number 2. Then by using the values of I, suppose omega from this 2 in this equation number 2. The equation number 2 मध्ये ह्या दोन व्हॅल्यू बाय करून आपण इथं पुट अप करू. Then the total kinetic energy of this rolling body is equal to this half m v square as it is plus half, instead of my here is m k square, and instead of this omega from this equation we can write omega as v upon r. Therefore, omega square is v upon r bracket square. इथपर्यंत पार्ट बघा लक्षात येईल का. आता काय करायचं ठिकाणी सिम्प्लिफिकेशन करू. Therefore, this total kinetic energy of rolling body is equal to this half m into k v square plus half m into k square into v square upon r square. आता या ठिकाणी टर्म काय करू आपण रिअरेंज करू. या ठिकाणी दोन टर्म काय करू रिअरेंज. Therefore, this half m v square plus this half m as it is to v square इकडे घेऊ in bracket k square upon r square. म्हणजे टर्मचा अर्थ बदलत नाही, फक्त आपल्या अरेंजमेंट साठी सिम्प्लिफिकेशन साठी काय केलं आपण या ठिकाणी हा k आणि v चा टर्म फक्त या ठिकाणी वेगवेगळ्या पद्धतीने. Therefore, this half m square, it is half m square and common, that is this half m v square in bracket. आता इथं जर याला 30 व्हॅल्यू आपल्याला ठेवायची असेल तर काय करावं लागेल 1 ने मल्टिप्लाय करावं लागेल प्लस k square upon r square. k square upon काय या ठिकाणी मॅग्निट्यूड व्हॅल्यू द्यायची r square, म्हणजे हाफ m square ला बघा याला 1 ने मल्टिप्लाय केलं पहिली टर्म मिळाली, हाफ m square प्लस याला मल्टिप्लाय केलं ही सेकंड टर्म मिळाली. म्हणजे टोटल kinetic energy of that rolling motion, that total rolling motion ची total kinetic energy काय आहे this half m square multiplied by 1 plus k square upon r square. म्हणजे लक्षात ठेवताना अगदी सिंपल आहे. लक्षात ठेवताना काय ठेवावं लागेल आपल्याला तर हाफ m square काय ट्रान्सलेशनल मोशन मध्ये kinetic energy multiplied by this 1 plus k square by r square. असे एक फॅक्टर लक्षात ठेवला की टोटल kinetic energy कोणाची मिळेल आपल्याला rolling motion. Thus, here in this lecture, we find the kinetic energy or the total kinetic energy of that rolling motion or the rolling body. Up to this, thank you.